Hey everybody, Brian here from quantlabs.net. Wanted to show you something fairly important. Wanted to show you how to calculate your implied volatility. I'm doing this in C++ instead of Python. Reason being, I'm trying to put all my algorithms and equations into a faster language like C++ and make a set of libraries from them and have basically Python call them. I've tested the Python calling C++ via a project called Boost Python or Python Boost. I verified that, so we're in the clear there. Now, in terms of the source of where I'm getting the source code from, this is from QuantStart, and this is pretty good code. But what we're after in all of this is the implied volatility, which is essentially this, and which is really the sigma. Now, I'm not going to walk you through the entire process of how this code works, because it's well documented and the comments are pretty good in the code itself. Because of that, as I move into my Xcode, which is my Apple IDE of choice on a Mac for C++. Now, let me just make a comment here regarding IDEs and C++. My favorite one is, out of all of them, is Visual Studio, a highly professional IDE. But as you know, my opinion on Windows, I've moved off the Windows. My next best alternative is what I could find on either Mac or Linux. Now, because I've chosen Mac, I'm obviously using a higher grade IDE from somebody like Apple. Now, there's other IDEs out there like Eclipse, NetBeans, and C-Line. I played with a lot of them, and I find them either buggy or just the process of running with them becomes a completely big waste of time. So I like my high-end IDEs, and Xcode for Mac is the one I prefer, and hopefully I haven't tested it yet, but be able to take the same code and move it into a Linux environment. So knowing all that, with the generated code is these functions, as you can see, and when I do run it, at the end of the day we get our implied volatility. And again, as I said, that is found here in the main function, or the main C++. And as I said, we're after the sigma. Here's all your parameters that are used. These are I'm not exactly a math genius here, but you can set these bisection parameters as well, and then run them in this function called interval bisection. But again, you're better off to read an expert's opinion from this guy, Michael Hall's, can't remember his name, but he's a PhD, so I'm sure he knows what he's doing. And we leave it at that. So we have a C++ version of implied volatility, which we can use in our system and have Python call it. Okay, hopefully that'll help you out, and I'll talk to you later.